What's up, everybody? Welcome back to another live stream from Scalar Learning. And today we are continuing this 5-day cram session for the SAT math portion. So we are on day 2 of 5. And again, this is really for all you guys out there who are taking the SAT this Saturday. So every day from Monday through Friday, I'm going through the full math portion of an SAT live on camera under time settings where you can see me problem solve and explain the problems in real time. And it's part of the fun is that a lot of times it's usually things that I haven't seen before. These are though, however, tests that I've already solved. Khan Academy has not released a new test yet, so I've taken all 8, but we're still going to go through. It's been a while since I've done test 2, so this should be pretty interesting and pretty fun. Again, there's 2 math sections, a calculator section and a no calculator section. Look, at the end of the day, the reason why I'm doing this, and by the way, guys, on Instagram, if you're watching and you want to see me tackle these SAT math problems, go to my YouTube channel and check out the live stream. Search for Scalar Learning on YouTube. You can also click on the link in my bio. So the reason why I'm doing this is because I'm trying to dispel the idea that there's simply tricks and tactics that you can employ to knock out the math section. You don't actually have to know the math. It's just definitely not true. And it's a marketing tactic, but in reality, it's a math test, and you do have to know the math. Along the way, I will show you ways within the confines of the mathematical understanding and reasoning of how to move through the problems more quickly, efficiently, and effectively. So that's what we're going to be doing today. Now, in between each section, I'm going to finish a section and then I'll pause. I'll look at all the questions. So make sure if you have questions along the way as I'm solving problems, type them in the comments. And then as soon as I'm done with the first no calculator section, I'll take a look at all of them, answer your questions, and then I'll eventually move on to the calculator section. All right, if you guys are ready, let's get into it. Here we go, practice test 2. So I'm skipping the verbal. Okay, next. Oh, whoops. Okay, math, no calculator. So we got 20 questions in 25 minutes. So we got a little bit more than a question a minute, or a minute per question. Without further ado, let's do it. All right, first question, we've got 5x plus 10 equals 6 was 10x plus 3. So 5x plus 6, I'm going to quickly solve for x, subtract 6 from both sides, 5x equals 4. And then we want 10x, so I'm going to multiply this whole thing by 2, and 10x equals 8. Therefore, 10x plus 3 equals 8 plus 3, which is 11. There's our answer. Next, which of the following ordered pair satisfies the system above? Okay, so we're going to have to do a little bit of plug and chug, but I can use some shortcuts. First of all, this nice top equation, we're seeing that the x value plus the y value equals 0. So we're going to need only combinations that are opposites of each other, meaning the positive and negative same integer. So it's only b or c would work, so we can get rid of a and d. And now let's plug in b into the second equation. So we got 2 times 3 is 6, and then that's plus 4 because it's a negative, and a negative cancels out. So this one looks like it's good. Just to double check, let's try this in here. Negative 2 times 3 is negative 6, and that's minus 4, which is negative 10, does not equal negative 10, so it's B. Let's go to the next problem. A landscaping company estimates the price of a job in dollars using the expression 60 plus 12 NH, where N is the number of landscapers who will be working, and H is the total number of hours. So H is the total number of hours the job will take using and landscapers. Okay, so like an example would be we have 5 landscapers, and then whatever, we'd say 2 hours for the whole job. Which of the following best interpretation of the number 12? Okay, so let's do it like this. Wait, is this what is the cost? So it's $12 per something. It looks like it's probably $12 per hour per landscaper. $12 per hour for each landscaper. So that's my assumption. So this is why I'm saying this, because think about it like this. If we have one landscaper for 1 hour, it's $12. 2 hours, that's 24. 2 landscapers at 2 hours, that's 4 times 12, which is 48. So it's essentially every hour a landscaper works, we're paying $12. So that sounds good to me. All right, next. Which of the following is equivalent? Look, when we're talking about equivalent, you can quickly, if you're unsure, look what they're doing. They're just factoring this guy, and that's a big tip. If you see something like this, your go-to instinct should be to factor. So let's factor this guy. So I'm going to start by factoring that first term. It's going to be 3a squared times 3a squared. I'm looking at this last term, and it's going to be 2b squared, 2b squared. My assumption is this all matches up, and it does. Look, this works because the middle term will be 6ab squared, which gets us this. Therefore, this is just perfect square binomial, because it's something times itself, so we can just rewrite it as this. And there's our answer right here. Okay, next. What is the value of k where x equals 7? This is just a plug and chug problem. So 2k squared plus 17 minus, and I'm going to right away plug in 7 for x equals 0, and then we solve for k. So I'm going to add 7 to both sides. We get 2k squared plus 17 equals 7. Now we do the opposite of square rooting. We square both sides to get rid of that square root. Now we got 2k squared plus 17 equals 49. I'm going to subtract 17 from both sides, and I get 2k squared equals 32 divided by 2. K squared equals 16. Therefore, k equals 4, right? Because we got to take the square root of both of these, and therefore k equals 4. Okay, next we've got xy plane line L is parallel to line K. What is the value of P? All right, check it out. If these two are parallel, that means they have equivalent slopes. So this is how we solve for this. I'm going to get these coordinates here, 0, -4. That's of line K. And the other one is 0 to -5, 0. Let's subtract down and calculate the slope of each of these. This is 0 minus -4, which is 4 y values over the x values. P minus 0 is P. And this equals this slope, which is 2 minus 0, which is 2, 0 minus -5, which is positive 5. Cross multiply, and we get 2p equals 20, and p therefore equals 10. Oops. Next, we've got x. Let's see, what is the value of a minus b? So we got xa squared over xb squared equals x to the 16th. This x is greater than 1. Don't freak out about that. It's just an extra condition to make sure we don't get an absurd answer, but it's not super important. So what I'm going to do here is I'm going to, first thing is we see something like this in the exponent form. We want to simplify, and we can combine. We have the same bases, so we can subtract these exponents. X a squared minus b squared equals x to the 16th. All right, hopefully what you should notice here, they give you this value a plus b equals 2. How does that fit into this? Hopefully you recognize that this is a difference of squares. So another big tip is just factor when you can factor. And so difference of squares always factors to this, right? So that's really helpful, because now I know that a plus b equals 2. So this can be replaced with 2. Therefore, now look, xx. When you have something like this, we can just make a new equation setting these exponents equal to each other. It's like I can remove this guy. And then now we solve for, what are we trying to solve? We're trying to solve for a minus b, so divide both sides by 2. And we get a minus b equals 8. All right, next. We've got n a equals 360 because you measure a in degrees of an exterior angle of a regular polygon is related to the number of sides n of the polygon by the formula above. If the measure of an exterior angle of a regular polygon is greater than 50 times 50 equals 360. It's greater than 50. What is the greatest number of sides it can have? Well, we can divide both sides by 50. It's not going to go in exactly. It's going to go in 7.2 times. Okay, so now so here's the question, right? Is the greatest number of sides that we can have, is it 7 or is it 8? Okay, so we're saying it's greater than 50, which means that, and you're not going to have like 7.2 sides. We're talking about a whole number. So as this goes up, let's see what is actually divisible if we go into 54 maybe. Wait. So anyways, as we keep kind of raising this degree up until we hit a whole number, this value is going to go down. Okay, as this one goes up, this is going to go down. So it's not going to be 8, it's got to be 7. Okay. The graph of a line in xy plane has slope 2 and contains the point 1, 8. The second line passes through the points 1, 2 and 2, 1. Intersect to AB. Okay, so here we go. Graph of line in XY plane. Slope of 2. Oh, you know what? If the two lines intersect at point AB. Got it. So what I need to do is I need to come up with an equation. So the first line will use point slope. So it's y minus 8 equals the slope of 2 times x minus 1. That's my equation there. And then the second one here, 2 minus 1, is I'm calculating the slope by subtracting down, so 1 over negative 1. So it's a slope of negative 1, and then I use point slope here as well. Y minus 2 equals negative 1 times x minus 1. So here are my two equations. If the two lines intersect at point AB, now let's find where they intersect. So I'm going to use a little substitution here. So I'm going to say, let's put this into point slope. Y equals, I'm going to distribute this guy, make it 2x minus 2, add 8. Y equals 2x plus 6, and then over here y equals distribute negative x plus 1, and then I'm going to add 2 plus 2, so it's y equals negative x plus 3. Set these two equal to each other, 2x plus 6, negative x plus 3. Add x to both sides, 3x, subtract 6 from both sides, we get negative 3, therefore x equals negative 1. So they intersect at negative 1, then I'm going to plug it in here. Negative 1 times negative is positive 1 plus 3 is 4. Y equals 4. So they intersect at negative 1, 4, and that's AB. And what's A plus B? That's negative 1 plus 4, which is 3. Next question. Which of the following equations has a graph in xy plane for y which is always greater than or equal to 0? Equations has a graph in the xy plane. Oh, got it. Okay. This is not going to be always greater than 0 because I can, like, you can even test out an example. I can plug in 1 for x and I'll get negative 1. I can plug in 1 for x, I'll get negative 1. This one will always be greater than 0 because this will always be positive because anything squared is always positive. So even if I get whatever I get in here, whether it's negative 1,000,000 or 100, it's going to be squared to become positive. So this is always greater than or equal to, it's just greater than or equal to negative 1, but this won't even go below 0. So this one could go, if I plug in 0, I go negative 2, 0, negative 2, 0, negative 2. So it's this guy. Whoops. Which of the following complex numbers is equivalent to this? Guess what? In order to figure this out, look at what they've done with the solutions. These equivalent ones, you want to look at the answers to get a hint. They've basically broken this up into two different things. So actually, no, sorry. They've gotten rid of the imaginary number in the denominator. That's how we typically simplify anything with an imaginary number. So how do we do that? Well, we have to multiply by the conjugate of the denominator where we just subtract the imaginary number. I'm going to show you why in a second. So now we multiply these two. This becomes, FOIL. So it becomes on the bottom 64 minus 16i plus 16i minus 4i squared, which is just positive 4. Because I squared is negative 1 times negative 4 is positive 4. These guys cancel out. So we have 64 plus 4. So on the denominator, we've got 68. Okay, that's pretty good. Now let's multiply the top. We've got 24 minus 6i minus 40i plus 10i squared, which again, I squared is negative 1, so it's minus 10. Combined like terms, we have 24, negative 10, that's 14. And this is negative 6i, negative 40i, negative 46i. Divide everything by 2, and I get 7 minus 23i over 34. And that's this one. They just broke it up into two fractions, right? It split 7 over 34 minus 23i over 34, but it's the same thing. Okay, next we have r equals f over n plus f. I can already have a feeling all they're doing is isolating f, showing a favorable views in terms of other variables. Look, This text can confuse you. If you look at the answer choices right off the bat, this isn't a variable isolation problem. We're just trying to get f by itself. So let's begin the process. This is problematic, so I'm going to multiply the denominator over here, okay, which gets rid of this. So now I have, and then I want these parentheses gone, so I'm going to distribute. So I'm going to say Rn plus Rf equals f. Now let's bring this f back over here. Rn equals f minus Rf. This is nice because now I can factor an f out, and I get 1 minus r, right? And if you're unsure about how I factored, look, if I redistribute, I come back to the same thing as what I had previously. That's how you know you did it right. Now let's divide both sides by 1 minus r, and here it is, Rn over 1 minus r, this guy. What is the sum of all values of m? So we need to solve for all values of m and then add them together. So let's see, we've got 2m squared minus 16m plus 8 equals 0. I can divide everything by 2 to simplify. M squared minus 8m plus 4 equals 0. This is definitely not factorable, so we got to use the quadratic formula, which is negative b, which is 8, plus or minus b squared, 64, minus 4 times a, which is 1 times c, which is 4. So that's 4 times 1 times 4, which is minus 16, over 2a. A is 1, so it's 2. 64 minus 16 is 54, 48, 8, plus or minus 48 over 2. I can pull out a 4 from this, right? Simplifying a radical, it's 3 times 16. So then I can take the square root of 16, which is 4, 8 plus or minus 4, square root 3 over 2. Divide everything by 2. And I get 4 plus or minus square root of, plus or minus 2 square root 3. Okay, so my two solutions are 4 plus 2 square root 3 and 4 minus 2 square root 3. And they want the sum of these, so we'll add them together. These two cancel out. 4 plus 4 is 8. Simple as that. A radioactive substance decays at an annual rate of 13%. If the initial amount of the substance is this, which of the following functions models the remaining amount after t years? Okay, this is definitely A, and let me tell you why. When we're decaying at 13%, okay, that means that after 1 year, well, if 13% is gone, we should have 87% left, and that's what this equation is showing. This is a tricky one where sometimes people might choose this one, like, oh, there's the 13%, but this would mean that after 1 year, we have 13% left, not that we lost 13%. So it's like you want to look for the missing piece out of that whole one to indicate the percentage that's leaving each year. So that's why that's correct. Okay, last one. Now, this is going to be the last really hard one of this section, and then when we go to 16, it's going to get way easier. So remember, if you're struggling on 13, 14, and 15, jump to 16 and 17, and usually 18 will be easier as well. Okay, again, equivalent to which of the following? Look what we've done. It looks like what have they done? It looks like they've tried to break it up into two fractions. So let's just give that a shot here. 5x, is that the best strategy? Okay, let's try it. 5x over x plus 3 minus 2 over x plus 3. It looks like this one is definitely out. The rest of these, it looks like we've gotten this to turn into 5 somehow. So let me see if I can figure out how to do this. So we need to factor x plus 3. Hold on here. So if I added on 5x, like I feel like it's this one, but I'm having trouble remembering the process. I can definitely go the other way. I can prove that this equals this, and that's what I'm going to do. All right, so I'm kind of drawing a blank. So if I do this, that 5 becomes 5 times x plus 3 over x plus 3, okay, minus 17 over x plus 3. I'm going to distribute, and I get 5x plus 15 minus 17, and this is all over one common denominator. And then 15 minus 17 is negative 2. And that's how, and so we get back to the original. So I just proved in the reverse way that this one is correct. It's not always the greatest strategy because I knew that this one was out. You could try and test it with this one, but it was probably either this or this. So I kind of roughly had an idea that this was right, and I quickly proved it, and now I'm moving on. Next, the sales manager of a company awarded a total of $3,000 in bonuses to the most productive salespeople. The bonuses were awarded amounts of $250 or $750. At least one $250 was awarded, and at least one $750 was awarded. What is one possible number of $250 bonuses? So let's assume that these two are awarded. So that's $1,000, right? And then we have 2,000 remaining, okay? I don't know. There's multiple answers. So let's say one possibility is 8, right? Because then another 8 $250 bonuses will give us $2,000. So that would be a possibility. Another possibility would be 1 $750 and 5, right? So we could do 5 or 8. Let's do 5. Both should be correct. Let me just make sure I did that right. So 1 2. Oh wait. No, I have to include the other 250. Sorry, not 8. It should be 9. Because within this is a $250 bonus, and then we're doing an additional 8 $250, so it's 9 in total. Okay, let's stick with that. In the equation above, A, B, and C are constants. If the equation is true for all x, what is the value B? Okay, so write it right. The other thing I said is, if you see this, you're not sure what to do, just start foiling, just start multiplying and distributing. So 2x times 3x equals 6x squared plus 10x plus 9x plus 15. Let's simplify and combine like terms. 6x squared plus 19x plus 15 equals ax squared plus bx plus c. All right, and what is the value of b? Okay, well, look, here's my value of a. It matches up. Here's my value of b. It's 19. C is 15. Simple as that. 19 is b. Okay, next. Look, anytime you see two triangles kind of like this, assuming CD and AE are parallel, we've got two similar triangles. I assume those are parallel. Let me just put this up here really quickly. Screenshot is this one probably here. Oh, it's not this one. This is from yesterday. Okay, well, anyways, in the figure to the left, yes, those are parallel, and then AD intersects at BE. What is the length of CE? Look, so these are, okay, let me just try and get this up here to explain, because I think I'm doing good on time. It's not that one. Huh, didn't work. It's weird. Hold on. There it is. Okay, so the thing is, look, these angles are equal right here. These angles are equal. And so the sides opposite those equal angles are proportionate. So that means 5 and 10 are proportionate. And if we're trying to find CE, that we also know that CB and BE are proportionate. Well, what do we see? We see a 2-to-1 ratio. That means we're going to see a 2-to-1 ratio here. That means CB over here is only 4. And now they're not asking for CB, though. They're asking for CE. Well, now that I've got CB, CE is simply 4 plus 8, which is 12. Okay. In the xy plane to the left, O is the center of the circle, and the measure of that is pi over a radians. What is pi a? Okay. So take this and this. All right, so we know that AOB is pi over A. Here's how I'm going to solve this, okay? I'm going to look at this as a triangle. Okay, so this is like this, and like this. And my triangle, since this coordinate is square root 3, 1, that means this length here is square root 3, this length here is 1. Well, guess what? This is a special right triangle. I can already tell you, because, well, I'm drawing a right triangle. Like, I'm drawing it down like this. But it's important. The reason why I'm doing it is because I can recognize that this is a special right triangle, and it's a 30, 60, 90. Okay, this is the 30, this is the 60, and this is the 90. And when that's the case, we have a relationship of 1 of the small side. This is square root 3, and this is 2. So this length here is 2. But the important part is I've identified the angles. This is a 30-degree angle. Well, they've put this in radians. So 30 degrees, to convert it to radians, we multiply by pi over 180, which equals, we can divide both of these by 30 and we get 1 and 6. So it's pi over 6. Well, that's the radian measures pi over a. Therefore, a is that denominator, which is 6. Okay, last but not least, system equations, a and b are constant. If it has infinitely many solutions, what is the value of ab? That means these two equations are equal if they're infinitely many solutions. So what I'm going to do is I'm going to look at the top one, and to get it looking more like this, I'm going to multiply it all by 5 because I recognize that constant will then turn to 60. And then 5ax plus 5by equals this. And guess what? This means that 5a equals 2. 5b equals 8. Actually, I don't even know if we needed to do that, but that's okay. So then we want the ratio of a over b. See, I made this more complicated, I think, than I needed to. Let's just do 5a over 5b, which equals 2 over 8. It doesn't matter. It's 1/4 anyways, because the 5's cancel out, and this is a over b, which is 1/4. So it should be 1/4. Right? We want a over b because that's a and b 1/4. Okay, cool. I actually don't have a lot of time left to check my answers. I think let me double check this one. Yeah, I felt pretty confident there. Let me just think about that last one more time. So 2, 8. So yeah, because then that one is divided by 5, so it's 2/5. 2/5 over 8/5. It's still the same thing. It's 2 over 8, 1 over 4. And then that one I was pretty comfortable with is 19. Let's just go for it. 55 seconds left. Let's see what we got here. Okay, see if I made any mistakes. No, boom. All right, got them all right. Hey guys, on Instagram, if you're watching, by the way, go to my YouTube channel and jump on the live stream so you can participate and see what's going on. Let me look at the questions now. Okay, here we go. Hi, right on time. What's up? Cool. So for number 7, instead of doing perfect squares, you can directly square root, right? Let me look at number 7. Right. For number 7, you can directly square root. Oh, yes. Oh, that's much better. That's a great point. You see, so that's a great observation. So what, sorry, who gave that suggestion? Yeah, Naw. So what Naw is saying is that the way that I solved it, yeah, was longer for sure. That's a much smarter idea. So he was saying square root both sides. Boom. You don't have to do all the crazy stuff that I did. And then this is just right away x over a, x over b, x to the b equals. And then the square root of this is actually, this is the only tricky part where it might get tripped up. Some people might say it's x to the 4th, but it's x to the 8th. Because you're taking, so what times what equals x to the 16th? It's x to the 8th. And then you'll quickly see a minus b equals 8. Great point. Madison, would you be able to explain question 10 further? Let's look at 10. Yes. This one, sure. Okay. First of all, they're trying to find the intersection point. They're trying to find the point at where these lines intersect. So whenever we're doing that, it just means a system of equations that we're trying to solve. And solving that system of equations gives us the intersection point. But we don't have the equation, so we have to derive those equations. So the first one, we can quickly throw it into point slope using a slope of 2 and a coordinate of 1/8. So point slope is y minus 1y value equals the slope, which is 2, times x minus the corresponding x value. Okay, so there's my first equation. Technically, this is all we need to do for that equation. The second one, I'm going to use point slope again, but first we need to actually calculate the slope. Whenever I'm calculating slope, I stack the coordinates and subtract down with the y's on top. So 2 minus 1 is 1, 1 minus 2 is negative 1. So the second equation is y I'm going to choose the top one, y minus 2 as my coordinate equals -1 times x minus 1. This is essentially all we need. Now we got two equations. Now we have to find where they intersect. So you can either use substitution or linear combinations by combining them. I opted to use substitution. So I isolated this equation and I got y equals 2x minus 2 plus 8 plus 6. This one I got y equals -x plus 3. And then I substituted this in for y. And then I solved. So then I got my a and b value, and then I added them together. So hopefully that makes sense from there. Who was that? Madison. So Madison, hopefully that makes sense. Okay, for number 15, can you make up a value of x and plug and chug? Okay, number 15. Yeah, you can. I mean, this is... Oh, wait, no, this is 14. Okay, sorry. Yeah, because that would have been hard. 15, yeah. Yeah, you could do that. So let me make sure, though. So you get 1, you get 3 over 4. Huh. I guess, yeah, you could. The only reason why I get nervous about that is because, like, if you just tested one number, it could just so happen be, like, seeing that first equation, if they wanted to be really tricky, right, they could have made it, let's see, 3 over 4. They could have made it something where it comes out to be 3 over 4. And then you plug in 1 for the top equation, you get 3 over 4. And you'd be like, oh, 3 over 4, it's the same thing. So, like, I would be a little wary about that. But if you're going to do it, plug in two different values and make sure it works for both values. But, yeah. Okay. Do you have any tips or tricks for reading? No, I don't really. Yeah, I did score really well in that section, but it's just because, like, it's just from my reading ability. I don't really know. I'm not, like, a great strategizer for that section. Mason, yeah, I'm going to do a test every day at 10:30 in the morning Pacific Standard Time. So that's when I started today. For number 15, you said polynomial division. I don't know. Let's try it. 5x minus 2 divided by x plus 3. So then we do 5. Oh my God, you're right. That is amazing. I didn't even think about that. So it's -17, and then it's 5 minus 17 over x plus 3. Oh, wow. That's so much easier. Yeah. All right, Madison, great, thank you. How did I know it was a special right triangle? It was as soon as I drew it out as a triangle and I saw that we had one, because I have those ratios memorized, square root 3 and 1. So, like, if the small side is 1 and the other side is square root 3, or the other one is a 45, 90, where it's 1, 1, square root 2, then I knew it was special right triangle. I got a perfect 800, and then I got a 740 on the math, so in the English, so 1540. Okay, guys, that is it for the no calculator section. Let's jump into the calculator section. Again, if you're watching on Instagram, go to my YouTube channel, click on the live stream. You can look in the description link, and you can find that link to join along right now. And let's finish reviewing this section. Now this is the calculator section, 55 minutes. I've got my calculator ready to go right here. So without further ado, let's begin. A musician has a new song available for download streaming. The musician earns 9 cents each time it's downloaded and that much each time it's streamed, which the following expressions represents the amount in dollars that a musician earns if the song is downloaded D times, so D times 0.09, and streamed S times 0.002, D times, and it's added together, so it's just this one clearly. Next, a quality control manager at a factory selects 7 light bulbs at random for inspection out of every 400 light bulbs. At this rate, 7 out of 400. At this rate, how many will be inspected if they produce 20,000? Look, it's just a ratio, right? This is the ratio, and we're trying to find this out. So another way you could do this, honestly, a shortcut, is if I multiply the top and bottom by 50, you could also cross multiply and solve, which is totally fine. I just see this as a little bit easier. This becomes 2,000, 20,000 on the bottom, and the top becomes 350. So right off the bat, now they're exactly equivalent fractions. X equals 350. L equals 24 plus 3.5 m. When an object mass is attached to other than a string, the string stretches to a length of L centimeters as shown in the equation above. What is m when L is 7? I'll just plug and chug. What is m when L is 73 plus 3.5 m minus 24 minus 24? 70, so it's 5349 equals 3.5 m. You can use a calculator, but I can tell you that if 7 goes into 49 7 times, 3.5 goes in double that, which is 14. What is m? Yeah, we're solving for m, right? 14. I'm just doing double checking the math. Plus 7 is 49, 73. Cool. Next. The amount of money a performer earns is directly proportional to the number of people attending the performance. The performer earns 120 when 8 people attend. How much money will the performer earn when 20 people attend? So this is again a proportion question. Let's simplify here first. This is 115. If I divide the top and bottom by 8, now we cross multiply and I get x equals 300. Again, see, like if your mental math is fast, you don't really need to rely on the calculator as such a crutch. I will when I need to be certain, but when I'm confident in my mental math, it's fast. Next, the performer uses 43% of the money earned to pay the costs involved in putting on each performance. The rest of the money earned is the performer's profit. 43. What is the profit the performer? So pay costs. The rest of the money's profit. What does the performer profit makes at a performance where 8 people attend? So that's $120. Wait, let me double check. Yeah, $120. So that means it's a simpler, easier way to do it is that means the profit is 57%. So we do 57 times 120. This is where I'm going to quickly pull out the calculator, save myself a little time. And it's $68.40. Okay. Next, when 4 times, I'm going to quickly translate, 4 times the number x is added to 12, the result is 8. What number results when 2 times x is added to 7? Okay. Divide everything by 2. Do x, I'll tell you why I did that in a second. 2x plus 6 equals 4. Subtract 6, 2x equals -2. And then I did that because they want, what is the result when 2x is added to 7? Well, 2x is -2, so I'm just going to add 7 to that, and then I get 5. So my answer is 5. I could have solved for x if I wanted to, but that's faster. Next, the equation represents this. Which of the following forms of the equation displays the x-intercepts of the parabola as constants or coefficients? Translation, you got to factor. That's it. The x-intercepts are the zeros, so we got to figure out if this is factorable, which I'm sure it is. X and x are the first terms. The last ones are what multiplies to +8 and adds to -6. That's -2 and -4. And that's it. If they said, hey, which one shows the vertex, we would maybe choose a different one, but they said which one shows the x-intercepts of the parabola as constants or coefficients here, 2 and 4. That's where it intersects the x-axis. In a video game, each player starts the game with k points and loses 2 points each time a task is not completed. Starts k points and then loses 2 points. If a player who gains no additional points and fails to complete 100 tasks, so that's 200 points, has a score of 200. What is the value of k? It's 400. Let's double check that math. I kind of did it fast. So k loses 2 points each task, so 400, and they lose 2 points, 100 tasks, 200. Yeah, it's 400. A worker uses a forklift to move boxes that weigh either 40 or 65 pounds. X be the number of 40, Y be the number of 65. X be 40, Y 65. Forklift can carry either 45 boxes or a weight of 2,400 pounds. Okay, so that means X plus Y is less than or equal to 40. I'm sorry, 45. because they're saying the total, because X is the number of boxes, Y is the number of boxes. So the total boxes can be less than or equal to 45. In fact, I can go through and eliminate probably some of these right here. C and D are gone. So it's either A and B because they have the wrong X plus Y inequality. Or a weight of 2,400. Well, how do we represent that? 40 times X, that's the weight of the X boxes, plus 65 times Y has to be less than or equal to 2,400. And that's here in A. Oh, wait. Hold on. Wait a minute. The 40 or a weight of 2,400 pounds. This is dividing by 40, and that doesn't make any sense. Yeah, this is X is the number. Okay, so I was just like processing for a second, but X is the number of boxes, and you have to multiply that times the weight, not divide. Just look like another question that I'd seen before that tripped me up. A function f satisfies this, and this function g satisfies this and this. What is the value of f of g of 3? All right, well, if g of 3 is 2, right, then plug 2 in for f. F of 2 is 3. Done. Composite functions. Tony is planning to read a novel. The table shows the information about the novel's reading speed and the amount of time he plans to spend reading the novel each day. If he reads at rates given in the table, which of the following is close to the number of days it would take Tony to read the entire novel? Okay. So there is reads 3 hours a day. Here's the only rate. So words per minute is 250 words per 1 minute. And he said he does 3 hours per day. So if I multiply this by 180 and 180. So 180 times 250, that's 3 hours. 180 times 250 equals. So he's reading 45,000 words per day. And there are, let's see, how many words? So there's about 350. So I'm just going to divide 350 by 45,000. 350 by 45,000. And it's about 8 days. So 8 is the closest. Okay. Right? I think that math all made sense. We'll double check this later when I have more time, but I'm pretty confident. Next. All right. On January 1st, 2000, there were 175,000 tons of trash in a landfill at a capacity of 325. So 175, and there's a capacity of 325. Okay, next. Each year since then, the amount of trash increases by 7,500 tons each year. If Y represents time in years, okay, so it's like I'm gonna multiply this by Y because it's like each year I'm adding 7,500. Which of the following inequalities describes the set of years where landfill is at or above capacity? So 7,500 Y plus 175,000, where it's greater than or equal to 325, which is the capacity. That's it. 7,500. Okay, so these are not. It's probably this one. Wait, let's see. What have they done here? Oh, I got it. So they combine these values. So 175,000. I'm going to subtract 175 from both sides. Get 7,500 Y is greater than or equal to 150,000. You could use a calculator for this if you're not sure. Feel pretty good about that. So 7,500 Y is greater than or equal to, nope. Y is at or above capacity. So this is, hold on, not that one's not right because 7,500 Y. Hold on. You know, it's backwards. This is not right. 325, no. 7,500. Oh, it's this one. Oh, yeah. They had it right here. They just flipped it. I got confused. Whoops. That's right there. My bad. Okay, next. A researcher conducted a survey to determine whether people in a certain town prefer watching sports on television to attending the sporting event. The researcher asked 117 people who visited a local restaurant. 7 people refused to respond. Which of the following factors makes it least likely this is reliable? Okay, look. You're asking if people want to watch something on TV or go to an event, but you're asking at a place where people are watching an event at, watching something on TV. So the fact that 7 people refused, that probably doesn't really matter. I'd say where the survey was given is the biggest issue. Sample size, who knows? I mean, it's not a bad sample size. The population size is irrelevant. Okay, next. According to the line of best fit in the scatter plot, which of the following best approximates the year in which the number of miles traveled by air passenger in country X was estimated to be 550 billion? Line of best fit, so don't use the dots. 550 billion is about, looks like 2003. Yeah, it's like right around here. That's it. Data analysis, check the grid, that's it. The distance traveled by Earth is about 580,000 million miles, Makes one complete orbit in a year. The following, which is close to the average speed of Earth in miles per hour as it orbits the sun, miles per hour. So it goes, 580 billion miles per 1 year. And then we need to convert this to hours. This is crazy. So then we have 1 year over 365 days. We have 1 day to 24 hours. So we got to put days, and then hours. These cancel out. And then so this will get us our answer. So it's basically 580,000 divided by the product of that. 5 million, 580,123,123 divided by 365 times 24. 66,000 miles per hour, roughly. That's the closest one. Next. The table above summarizes the results of 200 law school graduates who took the bar exam. If one of the surveyed graduates who passed, here's people passed, is chosen at random for an interview, what's the probability the person chosen did not take the review course? Okay, so we're choosing from somebody who passed. So there's 25 people. Out of 25 people, the chance that they did not take the review course is 7. So 7 out of 25. Okay. The atomic weight of an unknown element is approximately 20% less than calcium, meaning it's 80% of calcium. Atomic weight of calcium is 40, which is the best approximate weight of the unknown element. So 0.8 times 40, which is about 32. I think the common mistake would be you do 8, because it doesn't say it's 20% of calcium. It says 20% less than calcium. A survey was taken of the values of home in a county, and it was found that the mean home value was 165 and the median was 125. Which of the following situations could explain the difference between the mean and the median? Bottom line is, we have a higher mean than median like that. We have an outlier. We have one really high outlier, because it's not really usually going to affect the median as much. Means are very susceptible to outliers. This one. So maybe a few outliers is what that's saying. A few really expensive houses that skew the mean. A sociologist chose 300 students at random. Okay. Siblings. Total 2,400 and 3,300 at Washington. Okay, 2,400 there, 3,300 there. What is the median number of siblings for all the students surveyed? Okay. So if we're talking about median, we need to find the middle. This is a confusing question. But we've got a total of 300 students, right? No, sorry, excuse me, a total of 600 students, okay? So if we're talking about the median for all the students surveyed, we need to find that magic 300 or 301 value actually right in between those two. So look what's happening. Here's 120, and these are already ordered for us from least to greatest. That's great. So 120 plus 140, that's 260. Guess what? That 300 and 301 value is in this pocket, okay? So this is 260 is the first value, and then the next one is another 190. So we're within this pocket is the median, so the median value is 1. Simple as that. Based on the survey data, which of the following most accurately compares the expected total number of students with 4 siblings? Expected total number of students with 4 siblings at the 2 schools. Okay, let's see. So we've got 10 out of 300 at both, which is 1 out of 30. But remember, there are 2,400 students at Lincoln. So Lincoln, there would be, hold on, 240, 80. At Lincoln, it's 80. And then at Washington, see, I'm just multiplying the fraction here. It's 110. Okay, the total number of students for things at Lincoln, no. At Washington is 30 more than Lincoln, yeah. That's it. Next. A project manager, right, because 30 more, one was 110, one was 80. A project manager estimates that a project will take X hours to complete where X is greater than 100. The goal is for the estimate to be within 10 hours. Wait, what? Yeah. Within 10 hours of the time it will actually take to complete the project. The manager meets the goal and it takes Y hours to complete the project, okay? So we're basically saying that the difference between we're talking about an absolute value. The difference between how much it takes and the estimate should be within 10, okay? Because that's what I think that's what it's saying. I don't even see a purpose for this 100 to necessarily be in the equation. It doesn't matter so much. Meets the goal and it takes Y hours to complete the project. Which of the following inequalities represents the relationship? Yeah. So because we say absolute value because we're saying it could be over 10 hours or under 10 hours. That's within 10 hours. And if we then want to, I already can see it's got to be D because none of these don't have absolute value. This is the equivalent of absolute value because absolute value, remember, we bifurcate this into 2 inequalities. Y minus X is less than or equal to 10. Y minus X is greater than or equal to negative 10. And that's what this is showing here. Oh, it's saying these don't have the less than or equal to. So I guess that's none of them do. So it's not a red flag for me. The wording to me made me think it would be there, but that's okay. So it's this answer. At a large distance R from a radio antenna, the intensity of the radio signal I is related to the, okay, whatever. Look, once again, this is all just trying to trip you up. Look at the answers. All they're doing is they're isolating R squared. Which of the following expresses the square, whatever? So let's just isolate R squared. Done. I equals P over 4 pi R squared. Multiply, I'm going to multiply everything by 4 pi R squared to get that denominator going. So 4 pi R squared times I. And then we're going to divide both sides by 4 pi I. And that gets rid of this, this, and this. And there's my answer. P over 4 pi I. For the same signal, observer A measures intensity 16 times measured by observer B. The distance of observer A from the radio antenna. Okay, so we're talking about a fraction here of distance. Okay. So observer A measures the intensity. So here, and it's the same radio signal. And so R, so what value of R is going to give a difference of 16 times 4? 1 and 4. Okay. It's 1/4. Here's why. Okay. Because if we're basically, what's going to basically happen is when we plug in, let's say, let's do it like this. If I plug in 1, okay, I get 1 squared. If I plug in here 4 squared, this becomes P over 4 pi. This becomes P over 4 pi divided by 16, okay? This one is 16 times stronger because it's in the denominator, right? So it's like dividing by 16. So that's why I can see that if it's a difference of 1 and 4 for the R values, therefore the proportion is 1 over 4 or 1/4. Pretty sure that's right. We'll come back and double check that a little bit more carefully, but that's where my gut's going with that. Okay, next, the equation of a circle. All right, we need to put this into the proper circle form. So first thing we do is we get the x's together. We get the y's together, and then we got to complete the square. Remember, to complete the square, we take half of this term and square it, which is 4. And we take y squared minus 2y. Half of this is -1 squared is +1. So I'm adding a 4 and a 1 here, so I got to add a 4 and a 1 here. So then I can square this, and this becomes x plus 2. Not square, excuse me, factor. This is a perfect square. This is a perfect square, and this is a perfect square. Plus y minus 1 squared equals -1 plus 1 is 0 plus is 4. And remember, this is my radius squared. 4 equals radius squared, therefore radius equals 2. Next, the graph of the linear function f has intercepts a0 and 0b. A plus b equals 0. Which of the following is true about the slope of graph f? Okay, it's saying a plus b equals 0. Well, let's first calculate the slope. Not totally sure how to do this one, but let's subtract down. 0 minus b is -b. A minus 0 is a. So my slope is -b over a. And it's saying a plus b equals 0, meaning they're opposites of each other. Okay? That means that one is equal to the negative of the other. It means a equals -b, which means that I can just substitute in a here for -b, which is a over a, which means the slope is 1. That's it. Let's just make sure that makes sense. 2 and -2. Yeah, it makes sense. So the slope is 1 and it's positive, actually. Okay. We'll double check that one too, because I feel like I did it suspiciously fast. The complete graph of the function f is shown in the xy plane to the left. Which of the following is equal to 1? All right. Well, where's 1? F of -4. We're looking at the y value at -4. Yeah, it's 1, so 1 is good. 3 over 2. Here's 3 over 2 for the x, and yes, it's also equal to 1. F of 3, all. 1, 2, and 3. 2 samples of water or mass are heated at 60 degrees. One sample is poured into an insulated container, other is poured into a non-insulated. Samples are then left for 70 minutes to cool. The graph to the left shows the temperature of each sample at 10-minute intervals. Which of the following statements correctly compares the rates at which the 2 samples change? All right, so this makes sense. Non-insulated drops off very quickly and then kind of cools more slowly. This one is more gradual. The magnitude of the rate of change of the insulated is greater. No, that's not true. Magnitude is just like how much is it changing, and it's not true. At the beginning, it's not changing as much. The magnitude of the rate of change of the temperature of the non-insulated is greater than the insulated. That's not true, because look down here. The magnet, like up here, yes, but then down here is barely changing at all. 0 to 10 minutes and from 10 to 20, the rates of change of insulated are of greater magnitude. No, it's the reverse. 0 to 10 and from 10 to 20, non-insulated are greater magnitude. Yes, boom, boom, look at that. And then afterwards, I already know this is the answer. And then 40 to 50 and 50 to 60, insulated are greater. Yes, you can see it's bigger. In the, wait, did I? Oh yeah. In the xy plane left, ABC is a square, E is a center, coordinates C and E are 7, 2. It's an equation of the line that passes through point B and D. Let's get this up on the board here. So time-wise, I'm actually feeling pretty good because I've still got almost half my time left. And we're about to hit a patch of easy problems. 30 to 34 should be pretty fast. So anyways, now we say E is the center of the square. Okay. And then it says C and E are 7, 2, and 1, 0. This is an equation of the line that passes through both B and D. Okay. Okay, well, B and D, it's going to go through the center, 1, 0. Oh, I get it. And then it's also perpendicular to this line. So first thing I'm going to do is I'm going to find the slope of this line, which is easy because I have 2 coordinates. So stack the coordinates, oops, and subtract down. 2 minus 0 is 2 over 7 minus 1, which is 6. So the slope is 1/3. So if the slope of this is 1/3, the slope of this is the negative reciprocal because the diagonals of a square are perpendicular. So the negative reciprocal of that is -3. So now we've got, and then we can use point slope. So y minus 0 equals -3 times x minus 1. And then minus 0 is irrelevant. So there it is. Y equals -3 times x minus 1. Yes. Cool. Next. In the system of equations above, A and B are constants, which the following values A and B have exactly 2 real solutions. All right. I'm trying to think of a fast way to do this. Essentially, the A value doesn't really matter. It's that B value. Oh, no, the A value does matter. Okay, here's the deal. First of all, the B value is not going to be 3. If it's 3, it only has 1 real solution, so this one's out. It's either these ones. Now, if it's below 3, the parabola has to face up because we're talking about a line, and the parabola has to go up like this. So for this one where the vertex, so basically the B value is 2, which is the lowest point here. A's got to be positive, and it's got to go up, but it's not. So actually we can cross out A, so it's either these two. So here, it's above at 4, so it's got to be down. So we need a negative A value. This is positive, this is negative. That's the only one. The figure above shows a regular hexagon. Hexagon is a 6-sided figure with, 31 is where it gets easier. Figure above shows a regular hexagon which sides of length A. You know what? Let's do this. I don't know if we even need this picture up here, but let's get it up anyways. A. Okay, A. If the area of the hexagon is that, what is the area in square inches of the square? Okay, so the square is obviously, it's A all around, right? So the square is A squared. We know that, but we don't know what A is. So how do we calculate the area of a hexagon? This is how I would do it. There's probably a formula, but I actually don't have it memorized, and so I always break it up into triangles. Okay. So this makes a right triangle, and this is not only a right triangle, but because it's a hexagon, these are all 60 degrees, 60 degrees, 60 degrees. So that means when I split it in half, this becomes 30 degrees, and this is still an equilateral triangle in a hexagon. So this is a 30, 60, 90 right triangle. So what does that tell me? That tells me that now, if this is now A over 2, this little side here. This side is whatever the smallest is times the square root of 3, A square root 3 over 2. And this side here is going to be 2 times that, which is A. But we already know that, okay, because this side is equivalent to all these sides. But the point is now I can calculate the area of this little triangle here, which is 1/2 times this value times this value. So A over 2 times A square root 3 over 2, and then times 1/2. But I'm not going to do 1/2 because that would be just this triangle. If I don't do 1/2, then I'm calculating the whole area of this triangle here, which is better for me. So the area of that whole triangle is 9A square root 3 over 4. And how many of these triangles are there? 6, right? So I multiply this by 6, and I get 54A square root 3 over 4. And that's the total area of the hexagon, and that equals 384 square root 3. I'm going to divide both sides by square root 3, get rid of that. Multiply the 4 over here, so it's 54A equals 1200 plus 320 is 1536. I'll have to double check my math because that's a little dangerous. Then we divide both sides by 54 and get 1536. Whoops, that I probably messed up the math. Hold on. So then we do 384 times 4. 384 times 4 equals, no, it is 1536. And then divide by, hold on, let me make sure I did that right. Divide by 54. Divide by 54. Area in square inches of the square. Hold on. 28.4. And then, oh, wait. That's why I wrote this wrong. I thought that was a 9. That's why this whole thing is thrown off. That was an A. Okay, reset. You got to be careful. But that was my indication. I was like, wait, why am I getting a repeating decimal? That's weird. I didn't expect that. So this is a squared square root 3 over 4. And that's this triangle. Multiply that by 6, and that's the whole thing. And this equals 384 square root 3. Cross this out. And then we multiply both sides by 4. And we get 6a squared equals, what did I say, 1536 divided by 6. Divided by 6 equals that. And that's it. A squared equals 256. And we already said the area of this is a squared, so we're done. Okay, now we're going to get some nice, easy problems at the beginning of the free response. Coastal geologist estimates that certain countries' beaches are eroding at a rate of 1.5 feet per year. How long will it take for the country's beach to be eroded by 21 feet? Simple enough. Let's cross multiply, and we get 21 equals 1.5x. Divide by 1.5. You could use a calculator, but again, the trick is 21 divided by 3 is 7. 21 divided by 1.5 is double that. So it's 14 years. Just make sure that makes sense. I think that's right. Okay. Wait, did I read everything right? Yeah. Next, h hours and 30 minutes is equal to h hours. So remember, to convert hours to minutes, I multiply by 60, right? 1 hour, 60 minutes, 2 hours, 120. H hours and 30 minutes is equal to 450. What is the value of h? Subtract 30. H times 60 equals 420. Divided by 60. H equals 7. Next, in the xy plane, 3, 6 lies on the function. So what is the value of b? Well, let's just plug in 6 and 3 and then solve for b. So 6 goes in for f of x. Remember, it's kind of like y, essentially. Equals 3 times 3 squared minus b times 3 plus 12. 3 squared is 9 times 3 is 27 minus, I'll change it to 3b. Combine these guys, that's 39. Remember, it's a positive and a positive. Subtract 39. Negative 33 equals negative 3b. Divide both sides by negative 3, and we get b equals 11. In one semester, Doug and Laura spent a combined 250 hours in the tutoring lab. If Doug spent 40 more hours in the lab than Laura did, okay, so Doug and Laura spent 250 hours. Doug spent 40 more hours in the lab than Laura. How many hours did Laura spend? This is a system of equations. I'm going to plug this in for Doug. And I got L plus 40 plus L equals 250. That's 2L plus 40 equals 250. Subtract 40, subtract 40. And then 2L equals 210. L equals 105. So Laura spent 105. Therefore, Doug spent 40 more, right? So 145, and the two add up to 250. All right. A equals 18t plus 15. Jane made an initial deposit in the savings account. Each week thereafter, she deposited a fixed amount into the account. The equation above models the amount A in dollars that Jane has deposited after T weekly deposits. According to the model, how many dollars was Jane's initial deposit? The initial deposit is this value. It's like your y-intercept. It's the constant that's out here. So she had 15 in there, and then it looks like she put in 18 every week. Next, in the figure above, point O is the center of the circle. And then this, so our tangent and L and N respectively in the segment intersect point M is shown. If the circumference is 96, what is the length of LN? Okay, I'm going to need to draw this one, or write on it. Okay. Okay, so we've got this right here. This is what they want is LN. Oh, no, I'm sorry. They said the minor arc. Excuse me. They want to find this value right there. So if we want to find the minor arc, and the circumference of the whole thing is 96, okay? So this entire thing around is 96. Basically, we need to find this angle, okay? And the reason why is once we find this angle, we can do theta over 360 times 96, and we'll get our answer. Okay, so let's figure out how to do this. I can't remember exactly how to do this, so we're going to just kind of have to figure it out. I know that I know one theorem is that when we have a fixed point and it kind of has two lines extending from it that are tangent to the circle, both of these lines are equal. Both of these are obviously equal because they're both radii. This is a 90-degree. Okay, I see what to do now. This is a 90-degree angle because by definition of tangent, and then I'm going to draw a line through here. The reason why I'm just making a triangle, and I'm making a right triangle, but it's important to see, once again, this gives us a nice 30, 60, 90. How? Well, if this entire thing is 60 and I'm cutting it right down the middle, this becomes 30. This angle here becomes 60. Well, if this angle is 60, the same thing happens here, right? Therefore, theta is 60 plus 60, which is 120. So 120 divided by 60 is 1/3. 1/3 of 96 is 32. So the length of that minor arc is 32. And that looks right? It's about 1/3. So I think that's good. 2 questions left. A botanist is cultivating a rare species of plant in a controlled environment and currently has 3,000 of these plants. The population of this species expects to grow next year. And next year can be estimated from the number of plants this year by equation below. It's a recursive formula, meaning we need the previous year to find the current year, or this year to find the next year, so on. Constant K is the number of plants the environment is able to support. Okay. According to the formula, what will be the number of plants 2 years from now if K equals 4,000? Plug and chug. So currently has 3,000. So N next year equals, this year is 3,000 plus 0.2 times 3,000 times 1 minus 3,000 over 4,000, or 3 over 4. This will get us the next year, but this won't be 2 years. So that's 2 years from now. Okay. So let's use our calculator here. So 0.2 times 3, this becomes 1/4 or 0.25. So 0.2 times 3,000 times 0.25 equals 150. So the next year is 150, 150. So then we do the same equation to recursive formula, 3150 plus 0.2 times 3150 times 1 minus 3150 over 4,000. Okay, so 3150 plus, okay, 0.2 times 3150 times 1 minus d over 4,000. Oh boy. Okay, so let me make sure I got that right. 0.3, 0.2. Okay. It's not the greatest calculator when you're doing these types of calculations. I think I wrote that right. And then round to the nearest whole number. So I think it's 3284. So that sounds about right, hopefully. Next, the botanist would like to increase the number of plants that the environment can support so the population of the species will increase more rapidly. If the botanist's goal is that the number of plants will increase from 3 to 3,360, how many plants must the environment support? This is simple plug and chug. But now we're trying to, let me change the color of this pen here. Now we're trying to get it so that next year, which is the variable on the left, is going to make it to 3360. So what is n? And n is still at 3,000, right? Plus 0.2 times 1 minus 3,000 over k. K is what we're trying to solve for. So now we just solve for k. Simple isolation. Subtract 3,000 from both sides. We get 360 equals 0.2 times 3,000 is 6,600. Divide both sides by 600. That's a 0. 36 over 60, which is 12, which is 3 over 5. We're just reducing the fraction. 3 over 5 equals 1 minus 3,000 over k. So then I'm going to subtract 1. That's negative 2/5 equals negative 3,000 over k. I can cross multiply now if I want. So that's negative 15,000. Whoops. Let me make room. Negative 15,000 equals negative 2k. Divide both sides by negative 2. And k equals 7,500. All right, that's it. We're done. So 13 minutes to spare. Let's go back to the beginning. Okay, oops, I changed. That's dangerous. So 0.09. This one I'm good with that. 350. 7 out of 400 times 5 is 35. 2,000. 350. Yeah, that's definitely good. 73. I double checked that one. 120. So double is 240 plus half is 300. Yep. That looks right. More than half. 60 plus 7%. 840. Yeah. Just add it to x. 12 equals 8. 4x equals negative 4. 2x equals negative 2. And that's 5. Yep. That one was good. Good there. Definitely good here. Wait, let me just think about this one. Yeah, I'm good there. Yeah. So this one was 8 days. Let's just go through the numbers again. 250 words. There's a lot of red herrings in this one. There's things that you don't need. So 250 per minute. So I'm going to try and do it mentally. And then times 60 is an hour. So 6 is 1,200 plus 300 is 1,500. So 15,000 an hour. So 45,000 in a day. Yeah. Yeah, it's got to be about 8 days. Next. Okay. 320. Yeah, this is good. Yes. good on that one. It's pretty good on this one. If one of the surveyed graduates who passed the bar, so boom, out of 25, yeah. Yeah, 7 out of 25. Mm-hmm. Yeah, this one I was really good with. Yep. Yep, isolating r squared. Uh-huh. Yeah, this one I was a little... Okay, so let's just quickly redo this one and make sure I was on the right track here. Pretty sure, but anyways. Okay, so observer A is basically 4i, right? And observer B is I. Equals P over 4P r squared. So we're trying to compare the two r's. So then we'll multiply both sides by, here, let's multiply by r squared. So we'll just basically these by swap. So multiply by r squared divided by 4i. So 4i r squared. Okay. And then I'm going to square root both sides for all of these. So now I get r. On the top, I get r equals square root of p over 4 square root of pi I. That's radius like 1. So radius 2 is just wait a minute. 16 square root of p. 2i. Oh, sorry, I did that wrong. It's 16. There should be 16, not 4. I was like, what? Okay. That makes more sense. Then this one becomes 64. The square root of that is 8. Square root of that is 2 pi I. And then we take the ratio of these guys. Square root of p over 2. You know, I'm making this so much more complicated than it needs to be. I over square root of p over 8 is definitely right. Pi I. And then everything kind of cancels out except for the 2 over 8, which is 1 over 4. So I'm pretty confident. This one I'm pretty good with. Oh yeah, this one. A plus b equals 0. So like, let's just choose a value, 2, 0, 0, negative 2. So 2, 0, 0, negative 2. Yes, it's a positive slope. Okay, next. This one I was good. This one I was good. This one I was good. Yeah, I was pretty careful about this one. This one. 7 hours. Let's double check my math. 3, 9, 27. Negative 33. 11. Okay, I feel pretty good. I'm going to go for it. Wait, that was initial deposit. Yeah, $15. All right, let's do it. All right, fingers crossed. Let's see what I got, and then I'll answer questions. Review this. Yeah. All right, all correct. Sweet. Let's see who's asking what. All right. Mace, wait. A bird moves from that point at the speed of 10. What will the bird be? Hold on. I'm just trying to answer questions from the SAT. Yeah, Madison, are you still on? Because I see a lot of people have dropped off. So can you just let me know? Here. How do I see? All right, so Madison, just type something if you're still on. And then no, I'll hit up 29. M is half the value. Yeah, you Adam, this one for 36, you could use that rule. It just didn't come to me in the time. So that would have been a lot faster. It's a good point. Okay, no for number 29. Okay, this one is essentially, I mean, you can do it like this. Let me think about this for a second. 2. You could have, if you wanted to, let me just try this out. Plus 2. This would have been hard. Okay, the best way to think about this is a parabola, right? That first term indicates, really the sign of it indicates the direction it's going in. So if it's positive, it's going up. If it's negative, it's going down. And we know that the intersection of this y equals 3 is just a line. And my b value is telling me the starting point, where the y value of the vertex is. So what I said was, if the vertex is below the 3, meaning if it's 2 or 1 or something, it's got to be going up, and then it will have 2 solutions. If the vertex is right at 3, well, that's no good because that's just one solution. And if the vertex is above 3, it's got to be going down. So I looked for that magic combination, and this is the only one where it's above the function, and the a value is negative, which means it goes down, which means it hits it twice. Okay, guys, so that is it for the live stream today. I hope you guys found it helpful and useful. Again, I have my own SAT course. You guys can check it out in the description below. It's the week before the SAT. If you want to buy it, I'm giving you guys a massive discount, 75% off of the regular $200 price. You do the math and figure out what that cost is. So go ahead and get that if you're looking for additional practice problems and all of my practice explanations. Again, I'm going to be doing this cram session every day this week. So now we've done Monday and Tuesday. Tomorrow I'm going to do test 3. Thursday and Friday, same thing. Be here at 10:30. And then on Friday, I'm going to add something a little special. I'm going to go over some of my super tips that you can use on test day to really help you crack down on, especially on some of the more difficult problems with great time-saving techniques. Thank you guys so much for joining, and I'll see you guys next time. Take it easy.